What if Earth isn't the only life-supporting planet in the cosmos? What if there's another world, orbiting a distant star, holding the same mysterious conditions that cradle life as we know it? Welcome to the strange and compelling story of Exoplanet K2-18b, a super-Earth located over 120 light-years away in the constellation Leo. In today's video, we'll dive deep into what scientists have uncovered about this alien world and why some believe it might be one of the best candidates in the search for extraterrestrial life. Buckle up because we're heading way beyond the boundaries of our solar system. Discovered in 2015 by NASA's Kepler Space Telescope, K2-18b immediately stood out. Orbiting a red dwarf star known as K2-18, this exoplanet is roughly 6 times the size of Earth and 8 times its mass, placing it in the category of a mini Neptune or super-Earth. What's even more intriguing is that it lies in its star's habitable zone, the sweet spot where temperatures could allow for liquid water to exist. Located 120 light-years away, K2-18b isn't just a random discovery. Its unique position and chemical composition make it one of the most studied exoplanets. Scientists have focused their attention on it due to promising data collected via space telescopes like Hubble and James Webb. And unlike gas giants like Jupiter, K2-18b may actually have a surface, or at least a thick atmosphere where life-sustaining chemistry could happen. In 2019, astronomers made a groundbreaking discovery. They detected water vapor in the atmosphere of K2-18b. This was a massive breakthrough in the hunt for potentially habitable worlds. Water vapor is one of the core ingredients needed for life. But it didn't stop there. More recently, data from the James Webb Space Telescope hinted at something even more remarkable: the possible presence of dimethyl sulfide, DMS, a molecule that, on Earth, is only produced by living organisms. This detection, although still under review, raises the tantalizing question: could microbial life exist in the atmosphere of this distant world? While it's too early to make definitive claims, the chemical signals are encouraging. If confirmed, it would be the first time we've detected possible biosignatures on an exoplanet, a potential game-changer in astrobiology. Despite these promising signs, K2-18b is not Earth 2.0. The planet likely has a thick, hydrogen-rich atmosphere and a steamy interior, a very different environment from our oxygen-nitrogen-dominated skies. The pressure at the surface might be crushing, and temperatures could swing dramatically depending on its atmospheric composition. Scientists speculate that K2-18b might be a Hycean world, a new class of exoplanets with vast oceans under hydrogen-rich atmospheres. These oceans could be boiling, or they could be more stable. No one really knows yet. This makes it both a familiar and alien place at once. It's Earth-like enough to tempt our imaginations, yet exotic enough to challenge everything we know about life's requirements. The James Webb Space Telescope has revolutionized our ability to analyze distant planets like never before. By studying the way starlight passes through the atmosphere of K2-18b, Webb has allowed scientists to detect the fingerprints of molecules in astonishing detail. What was once guesswork has now become science backed by hard data. Using this advanced tool, astronomers have picked up signs of carbon dioxide and methane, gases that could point to biological processes. These gases, when found in balance with water vapor and possibly dimethyl sulfide, create a profile that's difficult to explain with just geological or atmospheric chemistry alone. While we're still far from proving life exists there, we now have the tools to ask the right questions and get real answers. K2-18b represents more than just a dot on a telescope screen. It is a beacon, a signal that we are entering a new era of discovery. This isn't about science fiction anymore. This is real data from a real planet, orbiting a real star. As we refine our instruments and expand our reach into the cosmos, the possibility of discovering life beyond Earth becomes more than a dream. It becomes an inevitability. If K2-18b does host life, it changes our place in the universe forever. It challenges our philosophies, our religions, and our sense of uniqueness.
Whether or not we find life there, this pursuit unites us in a common journey, the search for our cosmic neighbors. K2-18b orbits a red dwarf star, the most common type of star in the Milky Way. Unlike our Sun, red dwarfs are cooler and dimmer, but they live far longer.
Their longevity gives orbiting planets a stable environment over billions of years. However, red dwarfs are also known for violent flares, which could bombard nearby planets with radiation. If K2-18b has a strong magnetic field or a thick atmosphere, it may be shielded from these harmful bursts. Understanding how red dwarf systems function helps us refine where to look for life in the universe. You might wonder how scientists detect gases from 120 light-years away. The secret lies in a technique called transit spectroscopy. When K2-18b passes in front of its host star, some starlight filters through the planet's atmosphere. Molecules like water vapor, methane, and carbon dioxide absorb specific wavelengths of that light. By studying these absorption patterns, scientists identify the atmospheric composition without ever visiting the planet. It's like smelling a perfume and knowing what it's made of, just using light. Given that K2-18b is 8 times Earth's mass, gravity on its surface, if it has one, would likely be much stronger. You could weigh nearly twice what you do on Earth, depending on its exact density. Walking would be harder. Jumping might be nearly impossible. This intense gravity could affect everything from weather patterns to the way life, if it exists, has evolved. Adaptation to strong gravity would create entirely different ecosystems than what we know here on Earth. So far, no moons or rings have been detected around K2-18b, but it's possible they exist. Large planets often have moons, and moons can be fascinating places for potential life. Think of Europa or Enceladus in our solar system, icy moons with subsurface oceans. A moon around K2-18b could offer a stable environment, perhaps even more suitable for life than the planet itself. Future telescopes might help us spot these hidden companions. K2-18b has been proposed as a prototype for a class of exoplanets called Hycean worlds, short for hydrogen and ocean. These planets may have deep oceans beneath a thick hydrogen-rich atmosphere. Unlike Earth-like planets, Hycean worlds could host life in conditions previously thought too extreme. Scientists now believe that life could thrive in warm, high-pressure oceanic environments, a game-changing idea that broadens our definition of habitability. AI is revolutionizing astronomy. Machine learning algorithms now help process the massive amounts of data collected by telescopes like Kepler and Webb. In fact, AI has played a role in identifying potential biosignatures on K2-18b by detecting subtle chemical patterns. As AI evolves, it will enhance our ability to analyze distant planets faster and more accurately than ever before, bringing us closer to answering whether we are alone. On Earth, life relies on oxygen, but what about on a planet like K2-18b? Some scientists theorize that life could evolve to thrive in hydrogen-rich environments. Microbes on Earth have already shown the ability to survive in extreme conditions, like hydrothermal vents and acidic lakes. If similar microbial life exists on K2-18b, it might use entirely different biochemistry, perhaps even harnessing hydrogen as an energy source instead of oxygen. Detecting biosignatures, signs of life, is the holy grail of exoplanet research. On K2-18b, the potential presence of dimethyl sulfide, DMS, is incredibly promising. On Earth, DMS is produced by phytoplankton. If confirmed, it would be the first time we've detected a biosignature on another world. Even if life is not confirmed now, the detection opens the door for deeper exploration and refined criteria for future biosignature searches. K2-18b may have surface pressures far beyond what humans can survive, but that doesn't rule out life. In Earth's deepest oceans, organisms thrive under immense pressure and heat. Extremophiles like thermophiles and barophiles could provide a model for what alien life might look like on a planet like K2-18b. The rules of life may be far more flexible than we once believed. Finding water vapor in K2-18b's atmosphere was a milestone. Water is essential for all known life forms. Its presence means the planet likely has the right temperature range in atmospheric conditions to support some form of water cycle. While we don't yet know if it rains or snows there, the presence of vapor alone is a sign of dynamic processes that could support habitability. Let's imagine a future where space travel is advanced enough to reach K2-18b. Could we ever terraform it? The short answer: not anytime soon. Its thick hydrogen atmosphere, extreme gravity, and unknown surface make it a hostile environment for human life. But that doesn't stop sci-fi dreamers from wondering. Learning about planets like K2-18b teaches us not only about alien worlds, but also about the limits and possibilities of our own future in space. The James Webb Space Telescope, JWST, has given us sharper eyes than ever before. It can detect infrared light with incredible precision, allowing it to study exoplanet atmospheres in detail. For K2-18b, JWST helped detect water vapor and the possible presence of DMS. Future observations could confirm or disprove the existence of biosignatures. This telescope marks a new era in exoplanet science. Every time new data about K2-18b is released, headlines light up around the world. Why? Because the idea of life beyond Earth is a universal fascination. K2-18b is one of the few exoplanets that feels within reach of that dream. Public excitement drives funding, inspires young scientists, and keeps space exploration at the forefront of global conversation. Science fiction might be turning into science fact, and people are here for it. Despite all our curiosity, we haven't sent a probe to K2-18b, and likely won't anytime soon. It's 120 light-years away. With current technology, it would take tens of thousands of years to get there. For now, our best tools are telescopes and spectrometers. But who knows? Concepts like light sails, warp drives, or wormholes are being explored. Maybe one day, human eyes will see K2-18b up close. K2-18b reminds us that Earth is just one version of what a planet can be. The universe is filled with planetary diversity: gas giants, ice worlds, lava planets, super-Earths, and Hycean worlds. Studying these varied environments helps us understand the rules and exceptions that define habitability. Earth is not the only blueprint for life. K2-18b might just be a new chapter in the cosmic story. One crucial factor in habitability is a planet's magnetic field. Earth's magnetic field protects us from solar and cosmic radiation. If K2-18b has a strong magnetic field, it could shield any potential life from its host star's flares. However, determining the presence of a magnetic field from 120 light-years away is incredibly difficult. Future missions may develop ways to indirectly detect these protective shields on distant worlds, which could drastically change how we evaluate exoplanet habitability. Interestingly, planets like K2-18b, super-Earths, are far more common in our galaxy than Earth-sized worlds. This suggests that the conditions for life may be more widespread than we thought. Super-Earths range between Earth and Neptune in size and may have rocky cores, atmospheres, and even oceans. While they're unlike our home, their abundance makes them key targets in the search for life. K2-18b is just one representative of an entire class of potentially life-bearing worlds. It's tempting to imagine green-skinned aliens on K2-18b, but the reality could be far stranger. Life there, if it exists, might be microbial, floating in the atmosphere, or living beneath an oceanic layer. It might not even be carbon-based. The unique conditions on K2-18b mean that if life exists, it's likely to be very different from anything we know. Studying these differences expands not just our science, but also our imagination. K2-18b orbits close to its red dwarf star, meaning it's likely bombarded with intense stellar radiation. This can strip away atmospheres over time, unless the planet's gravity or magnetic field offers protection. The fact that K2-18b still has a thick atmosphere suggests it's either replenished regularly or strongly retained.
Understanding this resilience helps scientists model atmosphere survival on similar planets and better estimate how long they could remain habitable. Ever wonder what color K2-18b would appear to the human eye? Its hydrogen-rich atmosphere, combined with possible water vapor and methane, could give it a deep blue or even purplish tint. If clouds are present, they might reflect light, giving the planet a shimmering appearance. We can't capture direct images of the surface yet, but simulations based on known chemical compositions give us a tantalizing glimpse into its alien beauty. K2-18b takes about 33 Earth days to orbit its star. Because the star is cooler and dimmer than our Sun, that short orbit still places it within the habitable zone. This tight orbit also allows astronomers to observe multiple transits in a relatively short time, which helps gather more accurate data. However, being so close may also increase tidal locking, where one side always faces the star, creating extreme day and night sides. Seasons are driven by a planet's axial tilt. We don't yet know K2-18b's tilt, but if it's significant, the planet could have seasons. That would cause atmospheric circulation changes and potentially influence cloud coverage, weather, or even climate cycles. Understanding seasonality would tell us a lot about whether life could adapt to shifting environments over time, or if certain parts of the planet are more habitable than others. If K2-18b is tidally locked, one side always faces its star, bathing in eternal daylight, while the other remains in darkness. This could lead to extreme temperature differences, unless atmospheric currents redistribute heat effectively. In such a scenario, the terminator line, the area between day and night, might be the most stable and life-friendly zone. Some scientists suggest alien life could thrive in these transition zones. If K2-18b is covered in oceans with no land surface, life might float in its atmosphere, much like some Earth microbes do. These lifeforms could absorb nutrients from airborne particles, survive UV radiation, and reproduce in high-altitude clouds. It's a sci-fi concept that's becoming more scientific every year. Studying Earth's own extremophiles helps scientists imagine how similar life could exist on distant worlds like K2-18b. K2-18b has reignited interest in the Drake equation, a formula estimating the number of intelligent civilizations in the galaxy. Each promising exoplanet discovery adds more weight to the idea that we might not be alone. K2-18b checks off several boxes: size, atmosphere, habitability zone, and possible biosignatures. It's one more data point suggesting that life, even intelligent life, could be more common than we've ever believed. Standing on K2-18b, if you could, the sky might be darker than Earth's, lit by a faint red sun. Depending on atmospheric composition and clouds, it could glow pinkish or violet. Stars would still be visible, but the red dwarf's dim light might make them appear even brighter. The beauty of imagining the sky on another world is a humbling reminder of our tiny place in a vast, mysterious universe. K2-18b is sometimes described as a mix between Earth and Neptune. It's larger than Earth and may have a thick atmosphere like Neptune, but it also exists in the habitable zone. This comparison helps astronomers categorize exoplanets and find more like it. By identifying patterns among planets that straddle Earth-like and gas-like traits, scientists can prioritize which exoplanets deserve closer observation. Earth hasn't always been what it is today. Billions of years ago, it had a thicker atmosphere and was teeming with microbial life before complex organisms evolved. If K2-18b harbors life, it may be in a similar stage of planetary evolution. Studying such worlds could give us clues about Earth's own past and even help us understand how life first emerged on our planet. If we ever detect undeniable life signs on K2-18b, should we try to make contact? This question divides scientists and philosophers. Some argue it's risky, we might attract attention we're not ready for. Others say it's our duty to reach out. Even if no intelligent life exists, our decisions could shape how future generations interact with the universe. The ethics of space exploration are just beginning to be written. Believe it or not,
Amateur astronomers and citizen scientists play a role in exoplanet discovery and monitoring. Projects like Zooniverse allow people to help process telescope data. You don't need a PhD to contribute to the search for alien life. With more eyes on the sky, discoveries like K2-18b become a collective achievement, proof that curiosity is one of humanity's most powerful tools. K2-18b proves that we can't just look for Earth twins anymore. Habitability might come in many forms. Ocean worlds, Hycean planets, even rogue planets might support life. By expanding the definition of what a habitable planet looks like, we open up the universe to infinite possibilities. K2-18b challenges us to rethink what it truly means for a world to be alive. Sending a radio signal to K2-18b would take over 120 years to arrive. A reply, if there was one, would take another 120 years. That makes two-way communication nearly impossible by today's standards. But as technology advances, theoretical ideas like quantum entanglement or faster-than-light communication might make interstellar messaging more than just a dream. It's a wild thought, but what if K2-18b isn't just habitable, but inhabited by beings far ahead of us technologically? While we have no evidence of this, it's a possibility worth considering. Advanced civilizations could even be hiding in plain sight, masking their presence. Until we learn how to detect artificial signals or megastructures, we remain observers, watching, wondering, and hoping. Whether or not K2-18b harbors life, its study marks a major milestone in our understanding of the universe. It's one of the first times we've identified a potentially habitable exoplanet with real atmospheric data.